Good afternoon to all of you. Is my voice audible to you?
Yes.
Yes, sir.
Yes, sir.
Okay, that's fine. So, how are you all?
We are fine, sir.
Yeah, we're fine.
So, you are free. Is anyone other joining?
No, sir. This is
Okay, so can you introduce one by one?
yes. I'm Kongovel and studying ninth grade in Sishya Omar.
Yeah, fine. That's great.
Mm, My name is Nitish. I'm studying in ninth grade, Sishya same school.
My
That's
name is
also
Saran.
great.
Even I am studying ninth grade. I'm in Sishas Poema.
Oh, that's great. So, I'm your chemistry teacher. My name is Shogud Ahmed Khawaja. I teach chemistry to 11, 12, and each students. So, I will be your chemistry teacher for this session. So can you let me know that, do you know that which is your first chapter in chemistry? Have you gone through
Yes,
the
sir.
syllabus?
Language of chemistry.
Language of chemistry, sir.
Exactly, it is the language of chemistry. So in this language of chemistry, we have to actually study regarding the basic concepts and the principles of this chemistry, including we will see the various elements, the symbols of elements, isn't it?
Yes, sir.
Exactly. Uh, so just wait a second. I will just share the screen.
Hello, sir.
Yes, is my voice audible?
Yes, sir.
Okay, so can you see the screen of PPT?
No, sir.
No, sir.
Okay, wait just a few. So is it now visible to all of you?
So it's a black screen.
It's saying you've started screen sharing, but it's not
Exactly.
visible.
It will take a few seconds, then it will be completely visible. So is
Yes.
it now visible?
Yes,
Yes,
sir.
sir.
It's visible, sir.
Exactly. So yeah, just we have to start from this language of chemistry, isn't it?
Yes.
Yes, sir.
Exactly. So the first topic that we have to actually study, that is regarding the symbols of elements. But before that, can you first of all tell me among you that what is chemistry actually?
The study of
Study
or
of chemical components.
Study of, yeah, chemicals.
The study of chemical components.
See, actually, it is that branch of science which actually deals with the study of atoms, molecules, and their transformation. We can say just like this, isn't it?
yes, sir.
Yes, sir.
So it is that branch of chemistry which deals with the study of atoms, molecules, and their transformation.
Yes, sir.
Wait a second, it is not editable. So is this now visible?
So you didn't share screen yet.
Okay. I have already shared here. Just wait few seconds.
Yes,
Yes,
sir.
sir.
So is this whiteboard visible to all of you?
Yes. Yes, sir.
Yes, sir.
Okay, so we have to just go through this. Is it now visible?
Yes, sir.
Languages of chemistry. So I was just telling that what is actually chemistry. So I told that it is that branch of science which actually deals with the study of atoms, molecules, and their transformation, right?
Yes.
Yes, sir.
I will just write it here. That here we just study. One is the atoms, another is the molecules, and the third one is their transformation. So can you tell me what is an atom?
It is the smallest unit of life.
Yes, smallest unit of what?
Life.
Smallest unit of life. But there are particles which are smaller than this atom. Do you know that?
Subatomic
Subparticles of
particles.
atoms.
Exactly. We are having electron, proton, neutrons. Still, we are having the smaller particles like positron. We are having mesons. We are having. So this atom, it is not the smallest particle, but this is really small, but not very much small. So we see that atoms are actually that, or they are those small particles which actually take part in chemical reactions and they do not have independent existence, right?
Yes,
Yes,
sir.
sir.
So I will write that atoms, the smallest particle of matter which take part in chemical reaction. Is it visible?
Yes, sir.
Yes, sir.
Yeah, so smallest particle of matter which take part in chemical reactions. Have you seen the chemical reactions taking place
Yes, sir.
anywhere?
Yes, sir.
Yes, where?
Everywhere.
Yes, there are a lot of hundreds of reactions are taking place in our body and we don't know. And similarly, when our plants, they prepare their food, they undergo photosynthesis. So there are also the chemical reactions, isn't it?
Yes, sir.
Yes, sir.
Exactly. So chemical reactions are everywhere taking place. So let me write here that I have told that it is the smallest particle of matter which takes part in
A
chemical
chemical
reaction.
equation or reaction.
Chemical reaction, yes, and has no independent existence. What do you mean by this? What do you understand by this?
Cannot
Independent.
exist
cannot-
independently.
It
Exactly.
cannot
That means
just
they cannot
stay single.
exist independently, singly. Exactly, right. And has no independent existence, right? For example, let's say this is my hydrogen atom. So it doesn't exist as such. So this is incorrect to write H. H exists always as
H2.
H2, right?
H2.
Exactly. Similarly, oxygen atom we are having, so it has no independent existence. It exists as O2, right? Similarly, we are having
Yes, sir.
N2, etc. But there are exceptions. See, actually, science is such a subject in which you will find always some exceptions, right? For example, we are having noble gases. Have you heard the term noble gases?
Yes,
Yes,
sir.
sir.
Yes, sir. Founded
Noble,
in the tastes of air.
Atmosphere.
exactly. We are here having just helium. We are just having neon, Ne symbol. So helium, neon, we are having argon, we are having krypton. All these have independent existence, right? So that
Yes,
means
sir.
they can
Yes,
exist
sir.
as such because they are stable, they have complete their octet. We will study ahead the octet rule, and that is the we can tell why they are stable as such, why they exist as monoatomic, they are stable. So that means these are exceptions. They exist independently, but other atoms of other elements, they do not have independent existence. So have you got the definition of what is an atom?
Yes, sir.
Yes, sir.
Clear to all? Any
Yes,
doubt
sir.
here?
No, sir.
No, sir.
Yes, so simply we have learned that atom, it is that smallest particle of matter which takes part in chemical reaction. Now, let's see the chemical reaction. For example, you can see here we are having this hydrogen, let's say hydrogen atoms we are having. They react with oxygen atoms and they form water, right?
Yes, sir.
So water
Yes.
is a molecule. Now what happened here? So this is the molecule of hydrogen. This is the molecule of oxygen. So when they combine it, they form this water molecule. So this is the transformation,
Yes, sir.
isn't it? So I told that in chemistry, we study atoms, molecules, and their transformation, right?
Yes,
Yes,
sir.
sir.
So this is actually how this transformation is taking place here. So hydrogen, yeah, similarly, you can see here that magnesium, it reacts with oxygen. So it forms magnesium oxide, that's MgO. So here magnesium has reacted with oxygen, so it formed magnesium oxide. So this is also the transformation. So one element, it reacts with another, so it forms the new substance, that is the magnesium oxide, and this is having new properties, isn't it?
Yes, sir.
Are you
Yes,
getting?
sir. Yes, sir.
Exactly. So I hope that you have got that what is an atom, right?
Yes, sir.
Yeah, exactly. So then can you tell me what is a molecule?
A combination of multiple atoms,
Mhm.
or when atoms are grouped together.
Exactly. So that means molecule is simply group of atoms, right?
Yes, sir.
Yes,
So I
sir.
will write it here. What is a molecule then? So molecule, it is simply group of atoms. Molecule is group of atoms having independent existence, right?
Yes, sir.
Yes.
Having independent existence. Now we're getting.
Yes, sir.
So group of atoms having independent existence. So atoms, they were not having independent existence, but this molecule, it will definitely have independent existence, right?
Sir.
So just
Yes,
we
sir.
are having, this is our water molecule. Similarly, this is the carbon dioxide molecule, right?
Yes, sir.
So these molecules, they exist independently. For example, we are having glucose, that is C6H12 and O6. So molecules have independent existence, but atoms do not have, isn't it? Have you got this?
Yes.
Yes, sir.
Yes, sir.
Any doubt here?
No,
No.
sir.
No, sir.
So can you write the molecule of ammonia? Can you tell me the formula of molecule of ammonia?
N
NH3.
NH2 plus what? Oh,
NH2
okay.
plus H2 gives
No,
NH3.
ammonia will be NH3. It is NH3, right?
Yes,
Yes,
sir.
sir.
Yes. So in chemistry, what we actually study, we study these chemical reactions and then their transformation. So atoms, molecules, they combine and they form new molecules. For example, this is my calcium oxide, isn't it?
Yes,
Yes,
sir.
sir.
It reacts with carbon dioxide and it forms new molecule, new compound, that's your calcium carbonate, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
So this is calcium oxide, it reacts with carbon dioxide, it forms the calcium carbonate. So this is the transformation. This is the chemical reaction which actually take place when our elements, molecules react with each other. So they form new compounds, new products are formed, and we study these atoms, molecules, and their transformation in chemistry. I hope that you have understood what is actually chemistry, right?
Yes, sir.
Yes, sir.
Yes. So our first topic is the symbols of elements, right?
Yes, sir.
Symbols of elements. So first of all, can you tell me how many elements we are having presently?
100 and
Yes, 100. How many?
not sure, sir.
Not sure.
Okay, no problem. So you will remember that we are having 118 elements. How many? 100?
118.
Yes, exactly. So when these elements they combine, how many compounds will be there? There are more than 10 billion organic compounds. So it's really a huge number, isn't it?
Yes, sir.
Yes,
Yes,
sir.
exactly. You have to remember this, that whenever these elements they combine, they form a huge number of compounds. So elements, what are elements? Can you first define what is an element?
A single element of, a single atom of particular element.
First tell me, is it a pure substance or a mixture?
It's a
Element
pure
is a
Pure
pure thing.
substance.
Yes.
Exactly. Exactly. It is a pure substance, isn't it?
Yes.
sir.
So pure substance, which is made up of, which is
Same
made
kind of
of,
atom.
yes, only one kind of atoms, correct. Only one kind of atoms, right?
Yes,
Yes.
sir.
So there should be only one kind of atoms. So that is your element. So for example, if I will just talk of iron is an element, isn't it?
Yes.
Yes.
Iron, it is an element. So what is the symbol of iron? It is Fe, isn't it?
Fe.
Exactly. So just we are having sodium. Sodium is an element. It is
Na.
Na, atomic number 11. So iron is having atomic number 26. So we are having 118 elements. So element is any pure substance which is made up of only one kind of atoms, right?
Yes, sir.
Yes.
Yes. So first of all, it was the Dalton who gave symbols for these elements. They are known as simply Dalton symbol. Dalton symbols, right?
Yes,
Yes,
sir.
sir.
Dalton symbol. But they have then modified, they have been modified. But first you have to actually learn about these and Dalton, how Dalton gave the symbols for various elements. For example, for hydrogen, see, it is the first element of the periodic table, which we have to study in detail ahead. So hydrogen, its atomic number is 1. So Dalton gave the symbol for this one like this, circle and then dot inside it. So this is the symbol for hydrogen given by the Dalton. Got it?
Yes, ma'am.
Yes, sir.
Yes. So it is the symbol given by the Dalton in order to identify these. For example, for carbon, he gave the symbol like circle, and then it was just fill it completely here. You can fill this. So this was the symbol given for which one? Carbon, right?
Carbon.
Yeah. Similarly, for oxygen, he gave a symbol that is only he represented it by circle. There, it is not filled inside. The difference between carbon and oxygen, he told that it is empty and this one is filled, right? Are
Yes.
you getting? Is my voice audible?
Yes.
Yes,
Yes,
sir.
sir. Yes, sir.
Yeah, okay. So next he told that, for example, let's say we are having phosphorus. What is the symbol for phosphorus? According to
P.
Dalton, he told that for phosphorus symbol is same like this circle, and then it is, there are 3 lines joining together. That means it is this circle is cut it into 3 equal pieces, right?
Yes, sir.
Yes,
Yes,
sir.
this was the symbol given for phosphorus by the Dalton. Similarly, for sulfur, he gave the symbol like this. There is the circle, and then it is the plus sign here, like this. So it is the sulfur. Then similarly for iron, he gave symbol like this. It is the circle, and there he wrote I, right, like this. But these symbols, they were having limitation. It was difficult to draw these structure, draw these symbols, and also it is difficult to remember for which element what is the symbol, because all are having circle and some are then somewhere there is dot, somewhere it is fillet, somewhere there are 2 lines, somewhere there are 3 lines. Isn't it difficult?
Yes, sir.
So this
Yes,
was
sir.
not appropriate. For example, for copper, see, for carbon, he gave simply and the circle which was filled. But for copper, he gave the symbol like this. It's the circle, then there is written C. So it stands for copper. but it was confusing. So that is why it has been now modified. We are now having the modern symbols given according to the IUPAC rules. So there are some rules according to which we will give the symbol for various elements, whether they are discovered or they will get discovered in the future. We will give symbols accordingly. So that is your IUPAC. Correct?
Indian Union of Applied Pure and
Yes,
Applied Chemistry.
exactly. It is the International Union of Pure and Applied Chemistry. International. That means it is internationally accepted, right?
Yes, sir.
International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. So here rules are framed, and accordingly we give the symbols, we give the IUPAC name to the various compounds. So all the chemists internationally, they frame certain rules according to which we give them the IUPAC name or the symbols. For example, for hydrogen, since it is HYDROGN, so the symbol was taken the first letter and it is written as capital H. So this is the symbol for hydrogen. It's very easy to write, isn't it?
Yes,
sir.
sir.
Similarly, then it was helium having atomic number 2. So they told that now H we have already given, so we will just add the next element, that is the E. So it is the symbol He. So the first it is H, then E. So this is the symbol for helium. Got it?
Yes, sir.
Yes, it is very easy. So first letter you will write capital, and then second one it is written as small letter, right?
Yes, sir.
Yes, sir.
Exactly. So similarly, we are here having lithium, atomic number 3. I hope you remember the atomic number of various elements. Do you remember?
Yes, sir.
Yes.
Helium's 2.
Yes, you have to remember up to calcium. That's atomic number 20. Up to calcium, you have to remember. Isn't it?
Okay. Yes.
Getting? Yeah. So, for example, here, lithium, its atomic number is 3. So, its symbol is like this, L first capital and then I, it is the small. First letter, it is written as capital and then we write the small letter. So, lithium symbol is Li. Then we are having next, which is the next element?
Beryllium.
Exactly, it is the beryllium. So, its symbol is written as Be. Atomic number, it is 4, right?
Yes.
Okay, then let's move ahead. Next element is your boron.
Boron.
Exactly. So what is the atomic number?
5.
5. So its symbol is only B, right?
Yes.
Exactly. Okay, then we are having the carbon. So carbon, it starts with the letter C. So its symbol is just capital C, right?
Yes, sir.
Yes, sir.
Yeah, very easy to write. So then we are having just a nitrogen. So can you tell me the symbol of this?
N.
N.
Yes, atomic number it is 7, so its symbol is N. Then we are having oxygen. So oxygen, its atomic number is 8, and its symbol will be O. Then we are having next one is fluorine. Atomic number 9, and its symbol will be F.
L.
Got it?
Yes, sir.
Then we are having neon. So neon, its atomic number is 10, and its symbol will be Ne,
Ne.
isn't it? Yeah, so similarly, then we are having sodium. Up to calcium, we will see up to calcium. So sodium, its atomic number is?
Na. Oh, this atomic number is 11.
Yes, first tell me the so atomic number is 11, right?
Yes.
Yes, sir.
So I'll write it here 11. So its symbol is Ne. Now here is very important point. Can you tell me its symbol should be either S or it should be SO? Why it is Ne?
Because of the Latin name.
Exactly. It's actually derived from the Latin name. So can you tell me what is the Latin name of this sodium?
Natrium.
Exactly.
Natrium.
The Latin name is natrium, right?
Yes, sir.
So whenever you are not having this matchable symbol, so that means you have to understood that it is actually derived from the Latin name, isn't it?
Yes, sir.
Yes, sir.
Okay, then next element is the magnesium, right?
Yes, sir.
So what is the symbol for this magnesium?
Mg.
Mg.
Exactly, its atomic number is 12, so symbol is Mg. So then we are having next one is
Aluminium.
exactly
Aluminum.
aluminum. So this is having the symbol
Al.
Al.
Al. So atomic number is 13, isn't it?
Yes, sir.
Yes, sir.
Okay, then we are having next one is silicon. Atomic number 14. So its symbol is Si.
Si.
Okay, then we are having the phosphorus. So what is the symbol for this phosphorus?
P.
P.
Exactly, it is the P. Atomic number is 15.
15.
Yeah, exactly. Then we are having the next one is sulfur.
sulfur.
You have to remember them in order. So atomic number is 16, so it is represented by S, right?
S.
Then we are having this chlorine, next element, that is your chlorine, right? Its atomic number is 17. So what is the symbol? So for carbon, we have already written C, so it will be now Cl. Cl is the symbol for chlorine. Then we are having the argon, atomic number 18, isn't it?
Yes, sir.
Yes, sir.
So what will be the symbol?
A. R.
It is exactly Ar. Then we are having the potassium. So can you tell me what will be the
K.
K.
for potassium? It is K. So why? So therefore, definitely it will have Latin name.
For potassium, kalium.
Helium, right? Isn't it?
Yes,
Yes,
sir.
sir.
Is my voice audible?
Yes,
Yes,
sir.
sir. Sir.
Exactly. So
My voice is big.
Your
Yes,
voice
yes.
is, it's breaking, sir. Hello.
Sir left.
I know. I'm the host.
What? I think it's recording. I don't. Oh, shit. I mean,
Is my voice audible to you?
Yes, sir.
Okay, so there was some issue. So can you tell me what I was discussing?
So the atomic table for three times.
Exactly, we were discussing the symbols of various elements, right?
Yes, sir.
Exactly. So then I was just saying that we're having potassium. So actually potassium, it is derived from kalium, right?
Yes, sir.
That's why symbol is key. Then we're having the calcium, atomic number 20, right?
Yes, sir.
So its symbol is Ca, right?
Yes, sir.
Okay, you have now remembered these elements up to calcium. Can you also remember their atomic mass? That's
Yes.
also very important. So for example, we are having hydrogen, its atomic number is 1. So mass is also 1, right?
Yes, sir.
Are you getting atomic mass of hydrogen? It's 1, isn't it?
Yes, sir.
Yes, sir.
Similarly, helium. Can you tell me what is the mass of helium? Atomic number 2. So
4.
mass is 4, exactly.
Two. I mean, four.
Lithium, atomic number 3. What is the mass? It's 7.
7.
Yeah, exactly. Then we are having beryllium. Atomic number we are having 4. So mass is
9.
9. Boron, we are having atomic number 5. So mass is
11.
11. Okay, carbon 6. It's 12. Isn't it?
Yes.
Then we have nitrogen 7, 14. Oxygen 8, 16. Isn't it?
Yes.
Yes, sir.
And we are having fluorine, atomic number 9. So it's 18. Then we have neon, atomic number 10. So what is the mass? 20, double.
20.
Yeah, for most of the elements, atoms, you have to remember that their mass is double, right?
Yes.
Yes, sir.
Just
Nearly.
yes. Are you having any doubt?
So what
No.
is the atomic mass of helium?
Helium atomic mass will be 4. I have written down here 4.
Okay, sir.
Yeah. So then we are having sodium, atomic number 11. So its mass is 23. Right?
Yes,
Yes,
sir.
sir.
Okay. Then we are having the magnesium, atomic number is 12. So its mass will be 24. Similarly, aluminum, atomic number 13, mass is 27. Got it?
Yes, sir.
Yes, sir.
Yes, I hope that you are keeping note of these. So
Yes.
after aluminum, we are having silicon, right? Si symbol. So silicon, its atomic number is
29.
14. Yes, it is 28. 29 will
28.
be another isotope of this. So then we are having
Oh.
phosphorus, 15. So mass is 31, right?
Yes.
Yes, sir.
Yes, you will first remember their general atomic mass, average atomic mass. Then when we will study the isotopes, then I will tell you that we are also having atoms whose mass number is also different. For example, carbon. Carbon, its atomic number 6, mass 12. We are also having another isotope of carbon whose mass will be 13. Another isotope whose mass will be 14, isn't it?
Yes.
Yeah, they are the isotopes. So we will study them in detail, isotopes.
Okay.
So it is the phosphorus atomic number 15, mass is 31. Then we are having sulfur 16 atomic number. So mass will be 32. Isn't it? Then we are having chlorine atomic
Yes.
number 17. Yes, its mass is 35.5. So atomic mass can also be fractional, isn't it?
Yes, sir.
Yes.
Yes. So atomic can also be fractional.
Sir, I think your voice is echoing.
Is it now fine?
Yeah, now it's fine.
Exactly. So then we are having next one will be the argon atomic number 18. Isn't it?
Yes, sir.
Its mass is 40. Then we're having potassium 19, its mass is 39. Then we're having calcium atomic number 20, mass is 40. So can you remember these? These are very important. You have to remember the symbols, similarly the atomic number and the mass of these elements.
Sir,
Yes.
Any doubt here? Any question?
sir,
No, sir.
is
Yes,
the mass
yes.
number like a calculation by you can calculate it, or you just need to by heart?
You have to remember it. I told that it is nearly double. So it's actually experimentally determined with the help of an instrument known as mass spectrometer. Are you getting?
Yes.
Yes, with the help of mass spectrometer, we can calculate the mass of any element, any atom. So we can tell the exact mass of any atom with the help of this mass spectrometer. So you have to just remember it. Usually it is double. For example, see, it is the carbon atomic number 6. So mass is double 12. Nitrogen, it is 7 atomic number, mass is double 14. Oxygen atomic number 8. So mass is double 16. Isn't it? So for most of the cases, you will find
Yes.
that the mass is double than the atomic number.
Yes, sir.
But sometimes you will find the exceptions, just as I told, sodium atomic number is 11, mass is 23. Now why it is so, why it is greater than double? It is due to the excess neutrons. So it has actually, okay, I will write it here, that sodium, it has 11 electrons. We will study these subatomic particles in detail. So it has 11 electrons, it has 11 protons, but it has 12 neutrons. So that is why its mass is 23.
23 minus 11.
So mass you can calculate from these two, that is sum of proton and neutron. So proton it's 11 plus 12, so that is your 23. Got it?
Yes,
Yes.
Yes, sir.
Yes, exactly. But in case of carbon, can you tell me how many electron, proton, neutrons are there?
that's 6 electrons.
6 and
So it has 6 electrons, exactly. So it has also 6 protons.
Proton.
And how many
6
neutrons?
neutrons.
It has 6
Exactly,
neutrons.
exactly. It has 6 same number of neutrons. So that is why when you will sum up these 6 plus 6, so that will come out to be 12. So its mass is 12, double. Got
Yes.
it? Yes,
Yes,
yes.
Yes,
We will
sir.
study it in detail. So I hope that you have remembered these elements up to calcium, their atomic number, their symbol, and their atomic mass. Isn't it? Yes, it will
Yes,
be
sir.
very important, because when you will remember these, then we can also move ahead. Next topic which we have to discuss, that is the valency. So first of all, can you tell me what are valence electrons?
So electrons present
the
in the
electron-
outermost shell of the.
Exactly, exactly. These are the electrons present in
The outermost cell.
Outermost shell.
outermost shell of an atom. So that is simply the valence electrons. But what is then the valency?
So
Valency is the number of electrons. The
Mhm.
valency is the number of electrons given or taken to achieve stable electronic configuration.
Exactly, we can, that is also the definition of valency. So it is in simple language, you can say it is the combining capacity of an element, right?
Yes.
Combining capacity of an element, so that is known as valency. For example, carbon, it combines with 4 hydrogen atoms, it forms methane, right? So that means the valency of this carbon, it is 4, isn't it? Because it is combining capacity is 4, right? Because it has combined it with 4 other hydrogen atoms, isn't it?
Yes.
For example, okay,
Yes,
I will
sir.
give next. Nitrogen, it can only combine with 3 hydrogen atoms usually. So that is why the valency of this nitrogen, it is 3. Its valency is 3. Similarly, we are having, let's say we are having water, H2O molecule. So can you tell me the valency of oxygen?
It's 2.
2 minus.
That is the oxidation state. You have to tell the valency. So valency is always
2.
whole number. It is not. Yeah. So it is 2 here, because it is combined with 2 hydrogen atoms, isn't it?
Yes.
So just we are having hydrofluoric acid. So what is the valency of fluorine? It's 1. Fluorine valency, it is 1, because it is combined with 1 hydrogen atom, isn't it?
Yes, sir.
So you have to remember that one of the way to find the valency is to check the number of hydrogen atoms. How many hydrogen atoms are attached with this particular atom, that will be the valency. So one of the way
Okay.
to define valency, you will remember that valency is the number of hydrogen atoms, right?
Yes, sir.
Or number of halogen atoms. So sometimes we can also tell the valency from halogen atoms. So number of hydrogen atoms or number of halogen atoms. For example, let's say I'm having CCl4, carbon tetrachloride. So can you tell me the valency of carbon?
So it's 2.
No, it's 4 because
Oh
it is
wait, I'm
combined.
sorry.
Chlorine
Yeah.
valency is 2.
Chlorine, I have not told the valency of chlorine. I am just telling the valency of carbon. So it will be 4, right?
Yeah.
Yes.
Original 4.
So if now I am having, let's say we are having boron trifluoride, BF3. So what is the valency of boron?
3.
3.
Exactly, because there are 3 halogen atoms attached to boron. So valence will be 3. Okay, so what will be the valency of
What is
beryllium?
halogen, sir?
Okay, what are halogens? That's great. So whenever you have doubt, you can just tell me. So halogens are actually and those elements which are present in your group number 17. Group 17 elements are known as halogens. You will just find these elements in the periodic table. Just we are having fluorine, we are having chlorine, we are having bromine, we are having iodine, we are having astatine, we are having tennessine. These elements are known as halogens. And what are actually halogens? Why they are known as halogen? Halogen actually means salt forming. So they form salt, isn't it?
Yes, sir.
So
Yes,
can
sir.
you tell me the formula of common salt?
A
Na.
rock salt.
Yes, exactly. Rock salt. That is your sodium chloride, isn't it?
Yes,
Yes,
sir.
sir.
So you can easily find here that we are having chlorine here. So chlorine is your halogen. It is salt forming element, isn't it?
Yes, sir.
Yes, sir.
Got it? Any doubt here?
No, sir.
So even sulfur will come under this, right, sir?
Exactly. Sulfur. No, see, actually, salt is they are formed by these elements mainly. So that is why they are known as halogens, salt forming. For example, you are having potassium bromide. It is also your salt. So it contains Br,
Oh,
isn't it?
Fluorine, hydrogen, fluorine, chlorine, bromine, iodine, astatine, and tennessine.
Yes, fluorine, chlorine, bromine, iodine, astatine, and tennessine. They are your halogens.
okay.
Just we are having sodium iodide, that is NaI. So this is also your salt, sodium iodide, white crystalline solid. So that means here iodine is present. So iodine has formed this salt. So iodine, it belongs to the halogen, that is your group 17. We will discuss these elements in detail. Groups, what are groups, what are periods in the periodic table, right?
Yeah. Sir, the last
Yes, sir.
halogen you have written is Titan.
What?
This is the
Which one?
last. This is the last
Last is-
halogen you have written.
Yes, it is the tennessine. Tennessine.
Yes, sir.
Tennessine.
Yes, tennessine. We will study these elements in detail when we will study the periodic table. Then I will tell you what are these groups, what are these periods, and how to remember these elements, how to remember the atomic number. It's very easy to tell the atomic number. There is a trick for that. I will tell that when we will study, when we will go through the periodic table. Got it?
Yes, sir.
Yes, sir.
Any doubt here?
No, sir.
Okay,
Yes.
then can you tell me what is the valency of sulfur here in H2S molecule?
2. 2.
Exactly, because it's combined with two hydrogen
Hydrogen.
atoms, isn't it?
Yes, sir.
Okay, so can you tell me what is the valency of silicon here?
1. I mean
4.
4.
Exactly, because it is combined with 4 chlorine atoms, isn't it?
Yes, sir.
Yes, sir.
Yes, you have to just to check the number of hydrogen atoms and the number of halogen atoms. So that is just the valency here, correct?
Yes, sir.
But now if we are having oxygen, then how you can tell the valency? For example, if it is magnesium oxide, that's MgO.
It's either one or
It's 2.
The sketch is 2.
Yes, magnesium valency, it is definitely 2. So that means you have to double the number. For example, here oxygen, it is given 1. So you have to double it. So its double will be 2, right?
Yes, sir.
Yes, sir.
For example, if you are having carbon dioxide, what is the valency of carbon?
Sir, 2.
No,
I mean 1. 1.
no, it will
No,
be
it's-
4.
It is 2.
Why it will be 4? Because there are 2 oxygen atoms. You have to double 2 into 2. That's 4, isn't it?
Yes,
Yes,
sir.
sir.
So I will write it here that you can also define valency, that it is the double the number of oxygen atoms. Correct?
Yes, sir.
Yes, sir.
Double the number of oxygen atoms. So when there is oxygen, you have to double it, right?
Yes.
Yes, sir.
But when there is hydrogen or halogen, you have not to double. Any doubt here?
No, sir.
No, sir.
Okay, then can you tell me what will be the valency of, let's say we are having calcium oxide, CaO, calcium, what will be the valency of calcium?
Sir, 1. No, I mean 2.
It will be 2 because there is 1 oxygen, so you have to double. Double of 1, that is definitely 2, isn't it?
Yes, sir.
But if now it is like this, Li2O, can you tell me here the valency of lithium?
4. I mean 2. It's 2.
4. Oh, it's 2. It's
Mm.
2.
Yeah, it is a little bit confusing. You say that it is 2 because there is 1 oxygen, its double will be 2, but its valency will be 1. Now, why? Because here we are having 2 lithium atoms. It is Li2O.
Yes.
Have you got it?
Yes, sir.
Yes,
For
sir.
example, yes, see, just to check it out, if it was magnesium oxide, magnesium is only 1 there, so its valence will be 2, right?
Yes, sir.
But here, in case of lithium oxide, we are having 2 lithium atoms, right?
Yes, sir.
Yes, sir.
So that's why you have to take the half, so valency will be only 1. So this is very important. I hope you have noted down this.
Yes, sir.
Yes.
So can you tell me the valency of sodium oxide? That's Na2, sodium here.
So 1.
Exactly, it will be 1 because you have not to double here because we are having 2 sodium atoms, right?
Yes, sir.
Okay, so can you tell me the valency of zinc here? Zn is zinc.
2.
Exactly, it will be 2. So I hope that each and everything is clear. So any doubt, any question?
No, sir.
No, sir.
Okay, so I hope that you have just noted all these points which I had discussed. So first we started with what is actually chemistry. So I told that it is the branch of science which deals with the study of atoms, molecules, and their transformation. Then I defined what is an atom, what is a molecule, how they react, how reaction takes place. Then I told that what is the symbol of various elements, isn't it? Like Dalton
Yes.
symbols and now the present IUPAC symbols. And then we discussed a little bit regarding valency, correct? What are valence electrons and what is
Yes.
valency, right?
Yes, sir.
So any doubt, any question here?
Sir,
No,
could you repeat the lithium oxide by find the valency?
Lithium oxide, I told that it is Li2O. So see, there are 2 lithium atoms. So its valency of lithium, it will be 1. For example, how you can know it from the chloride. Lithium forms chloride like LiCl. So what is the valency? So valency is 1. Similarly, lithium forms hydride like LiH. So here it's also only 1 hydrogen, so valency will be 1. So got it now?
Yes, sir.
sir, I have a doubt.
Okay, tell me.
So, like we have learned that we can make salts with sulfur, but they're insoluble in water. So, but is it still a salt formation method?
Which one? Can you give the example? Which compound of sulfur?
Like iron plus sulfur gives iron sulfide. It's still
Exactly.
salt.
We are having this iron sulfide. Yes, it is an ionic compound.
So, but is it a salt formation?
It will not be soluble. See, actually, there are salts which are soluble and some salts are not soluble. For example, okay, I will tell you, for example, if I will write magnesium sulfide, so your doubt is it is a salt or not. So definitely it is a salt because it contains ionic bond in it. There is ionic bond. We will discuss in detail what is ionic bond, what is covalent bond, isn't it? So
Yes, sir.
any salt, it should contain ionic bond. So magnesium sulfide, it contains ionic bond, so it is a salt. Got it?
Yes.
Yes, sir.
Yes. Okay. Any more doubt?
No.
So let's stop today's topic here then. See you tomorrow in the next class. Wish you all the way best.
Thank you, sir.
Most
Thank you, sir.
welcome. Have a nice day.
Thank you, sir. Bye.